Good morning, all of you. In today's lecture, we are going to discuss the concept of data abstraction and data independence. So, first concept is data abstraction. So, this abstraction term is derived from the concept of object-oriented concepts. So, you might have learned about C++ and Java. So, there they use a concept of abstraction. So, what is abstraction? Abstraction is an act of representing essential things and hiding the background details. See, I will give simple example, real life example to understand the concept of abstraction. Suppose person A want to teach to person B how to drive a car. So in that case, what is expected information from person A that has to given to person B? The information that how to accelerate a car, how to apply the brakes, how to handle the steering. These are some necessary information that person A has to give to person B. But instead of this information, suppose person A is telling to person B what is the structure of engine, what is the manufacturing date, how it is being manufactured, what is the company of manufacturing, whether this is a relevant information to person B. So the answer is no. So in that case, suppose this information is given to person B, it will create a lot of confusion. So what is expected? Relevant information. So this is what a concept of abstraction. So this abstraction is also the concept used in case of a database also. Generally, the concept of abstraction is used to remove the complexity or to avoid, or you can say hide the complexity of a system from the user. Now we'll take an example of banking system. All of you are having account. Most of the time we go to ATM to withdraw the money. So at that time, whether you know which database is used by your bank, and suppose you are having account in one bank and you are withdrawing a amount from another bank, say in that case what query will be executed, how many records are there in the table, whether this information is given to the user? No, this information is not given to the user. Why? Because it increases the complexity. Okay, it creates a lot of problem for the user. But what is the main objective of user? To withdraw the money. User is not able, means not bother about what database they have used, what query that they have fired. So this information is intentionally being hidden from the user. So this is what the abstraction, which is very important concept that is used in case of a database. So in this diagram you can able to see there are three levels are there. So physical level, logical level, and the view level. So as you move from bottom to top or top to bottom, what you observe, if you move from bottom to top, the level of abstraction increases, and if you move from top to bottom, level of abstraction is going to decrease. So here we'll discuss what information is known to the user at every level. So we'll start from physical level, which is also called as a internal schema. So at the physical level, user will know how the data is stored in the database. Okay, how the data is stored in the database, that information is known to the user. Whether in case of a system, Oracle database is used, MySQL used, or what kind of database is used, and what is the structure. So that information is known to the user at physical level. As you go one level up in the logical level, so what information is known to the user? What data is stored? Maybe the case that suppose I am creating a employee table. So in that case, user will come to know that employee data is stored in the table. So logical level will tell you what data is stored in the database. So this is intermediate level of abstraction. Then suppose again you go one level up, then you will find a view. View is a highest level of abstraction, where intentionally you will hide some kind of details from the user. Now I will give a simple example. Suppose in case of your bank has created one table called as a bank, and in that table they maintain information about customer, account number, balance, address, contact number, email ID, and so on. So out of this, bank want to display only three attributes. What are they? Name of a account holder, their balance, and account number. So bank want to hide rest of the attributes from the user or any particular user, so they can do this by using a view. Now in the next concept we are going to discuss in detail what is the concept of view, how view can be used, and what is the main objective behind view creation. Now the next topic is view. So view is nothing but a virtual table or logical table. The main intention behind creation of view is that it is being created for security. It helps to impose the security on the database. Now question arises, how it helps us? By restricting the user from accessing only few attributes of the table. That means suppose in my table 10 attributes are there, out of which I want to show only 3 attributes to the user, then I can create a view. So view is a virtual table or logical table which derive its data from base table. Means view does not consist of any kind of data, it's totally a empty table. Whenever a particular user make a request to that view, it will transfer this request to the original table, and from there it will fetch the database. So it's only a interface through which you are interacting with the database. So view contains row as well as a column, just like a real table. But what is the difference between real table and view? View does not consist of any kind of data, but your original table will consist of a data. So it acts as a interface for one or more table. That means you can create a view for more than one table also. Now again I will give a simple example of a customer and order. Suppose I have created a two table. One table is called as a customer, where I will store a customer details such as customer ID, customer name, address and contact number. And another table I have created with the order table, which consists of customer ID, order amount and order date. Now based on this, if somebody asks me give me the names of customer whose order amount is greater than 10,000, so in that case how will you get this data? So in that case you require two table. Why two table? Because from customer table you will get customer name, and from order table you will get the order amount. So that's why you required a two tables. So in order to resolve such kind of query, you can create a view. That means for customer and order table we can create only single view that acts as an interface. So in the background more than one table may also be there. That's why it is written it acts as an interface for one or more table. Now next is, what are the benefits of views? So what are the benefits are? It can restrict the user from accessing specific column. As I told you, suppose in my table 10 attributes are there, I can give access to only few attributes. Then it represent a subset of data contained in table. That means out of the 10 I am giving access to user about only 3 attributes. That means I can say that it is a subtable. Then it can join and simplify multiple tables into a single virtual table. That means I will create a single interface to which a number of tables can be backed. Then it can hide the complexity of a data. We have taken example of ATM. Intentionally from user the database information is being hidden, and it takes very little space. Why it takes very little space? Because it does not consist of any kind of data, it's only a empty table. That's why we can say that we will take a very little space. Now next is syntax, how to create a view. So it has simple syntax: create view, view name as, then select column name from table name where condition. So here we have taken one example. We have just created one table called as a sales. So in the sales table 4 attributes are there: salesman number, name, city and commission. So in that case what is my aim? My aim is to only provide information related to salesman who belongs to city Pune, because in this particular sales table information from different cities may be there: Nagpur, Mumbai, Kolkata, Bangalore, but I am interested in giving information related to Pune city. So for that purpose I will create one view which only provides information related to Pune. So how can we do this? Create view. I have given the name to that view as Pune team. As what are the attributes that I want to show? In that case, only salesman number and the name. What is the name of table? Sales. And what is the condition? City should be Pune. So this is how you can create a view. This is another view where I want to provide details of salesman who belongs to all city, but I don't want to show the commission earned by salesman. So how can I do this? I can do this by simply using this create view all supplier. As I want to display three attributes: supplier number, name and the city. Again the table is sales. So whenever we are firing any kind of query on Pune team or all supplier, that query is ultimately transferred to sales table, and from sales table user will get the data. So this is how simple query: select star from Pune team. So this query is transferred to this view. From here this query is transferred to original table, and from here information is given to the user. And this is simply a command to drop a view, to delete a view from the database. Drop view name. So I hope you understand concept of view. Now the next concept is of data independence. Actually data independence is a concept of making change at one level without having change in the another level. So what is data independence? So it's a concept, or we can say feature or characteristics of a database which allow to make a change the schema at one level without having change in the schema at the higher level and application program. So there are two types of data independence. One is a physical data independence, and second one is logical data independence. So this is again based on data abstraction architecture, where we discuss physical, logical and view level. So what do you mean by physical data independence? So it's the ability to make a change at physical level schema without having change in the logical level schema. Now I will give simple example to illustrate this. We know that what information is known to the user at physical level, how the data is being stored. Suppose I change the physical storage or index or hashing, does it make any kind of change to the data present in the table? So answer is no. So this is what a physical data independence. Suppose I make any kind of change in the structure, then it doesn't make any kind of change in the data present in the table. So this is what an example of a physical data independence. Similarly, there is a concept of logical data independence, in which it's the ability to make a change at logical level schema without having change in the view level or external level schema. So what is the meaning of that? We'll take another example. Suppose I change the data type of particular attribute, does it make change in the visibility of that attributes to the user? So answer is no. Suppose I change the attributes, so data type of an attribute, it doesn't make any kind of change to the view that is created for the user. That means it is a logical data independence. So this is what a concept of data independence. So in this lecture we discuss about two concepts. One is a data abstraction and data independence. Abstraction means representing essential thing and hiding background details, whereas data independence means making change at one level, it does not affect the another level. Thank you.